Alright, so quick little reminder on scientific notation. So in scientific notation, it's really good for notating really big numbers like distances in space, or notating really small numbers. For example, the mass of an particles of an atom. Excuse me. So essentially, we have a bunch of numbers in standard notation here, a bunch of numbers in scientific notation here, and the overall form of scientific notation is you're going to have one whole number, a decimal, and then you can have any number of supporting numbers after the decimal point. Typically, you don't keep more than 2 or 3. You always have the multiplication x, which is a little wonky, I know, times 10, and that's always going to be there, and then you're going to have an exponent. Now your exponent can be any whole number between any negative or positive whole number. So the idea here is we have 40,000, and so right now the decimal place is right here. And obviously this number is greater than 1. So to move the decimal place 1, 2, 3, 4 spaces, essentially we had to say 4 times 10, I can't read that, 4 times 10 to the 1, 2, 3, 4. That's about it. So here, now we have a number smaller than 0. And so we're going to move the decimal place in the opposite direction. 1, 2, 3, 4, 5, 6 spaces. So we have 4 again times 10, but this time we had to move the decimal place over to make a smaller number into a whole number. And so we have a negative exponent, since we move it to make a small number look bigger. So that's 1, 2, 3, 4, 5, 6. It's the negative 6. So essentially, if you have to move the decimal place this direction, you're going to have a positive exponent. If you're moving the decimal place this direction, it's a negative exponent, which I realize is the opposite way that the number line works. But think about it. You're taking a number larger than 1, or larger than a number with just one number before the decimal place, and you're trying to shrink it down to have just one value before the decimal place. In this case, our decimal place is here. We already have only one number to the left of the decimal place, so we can still write this in scientific notation, because we still have 2 times the 10, but 10 to what power is equal to 1? Well, you'll remember in our exponents lessons that 10 to the 0, or anything to the 0 power, is 1. So therefore, 2 times 10 to the 0 power is going to be just plain old 2. To go from scientific notation to standard notation, you just work backwards. So you go 3.2, and if it's times 10 to the 6, we're going to move sorry. We're going to move the decimal place 6 spaces to make the number larger. 1, 2, 3, 4, 5, 6. And then we fill in the zeros. So we get 3,200,000. Same idea here. We have 4.332. Let's move it in the negative direction, so we're expanding it. So we're going to have a much smaller decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9. There we have it. Finally, 10 to the 0 power is just 1. So we just end up with that. So It's really not too hard to change standard notation to scientific notation, and the other way around.